Have you ever looked around your city and wondered what it's all made of? The sidewalks you walk on, the tall buildings that scrape the sky, the massive bridges that cross rivers. So much of our world is built from a single gray material, concrete. But how does this simple sludge turn into a rock so strong it can hold up our entire world? Making concrete seems a lot like baking a cake. You take a few simple ingredients, mix them together, and wait for them to harden. The recipe has three main parts. First, you need aggregate, which is just a fancy word for sand, gravel, and crushed stones. Next, you need the most important ingredient, cement. This fine gray powder is the magic glue that will hold everything together. And finally, you add water. When you mix them all up, you get a thick, flowing liquid that can be poured into almost any shape you can imagine. But this leads to a hidden problem that scientists and engineers had to solve. How do you create a material that starts as a liquid but becomes strong enough to last for centuries? Think about it. We need to build dams that hold back powerful rivers and foundations that support the weight of a skyscraper. A simple material that just dries out like a mud brick would crumble under that kind of pressure. We needed something much, much stronger. The secret doesn't come from the stones or the sand. The incredible strength of concrete comes from a chemical reaction. Let's look closer at the key ingredient, cement. It isn't just crushed up rock. To make cement, materials like limestone and clay are heated in a giant kiln to over 400 degrees Celsius. This intense heat causes a chemical change, creating new compounds that have a special property. They are hungry for water. When you finally add water to the cement powder, it's not just making a wet paste. You are kicking off a powerful chemical reaction. This process is called hydration. It's the true source of concrete's amazing strength. As soon as water molecules meet the cement particles, they begin to react and form new structures. Tiny needle-like crystals start to grow on the surface of each grain of cement. Imagine millions and millions of tiny branches sprouting in every direction.